In the previous videos on AWS step functions, we've been using the Amazon console to trigger the workflows. In this video, we will learn how to trigger the step functions programmatically from your application code. I will show you how to start step function executions from an ASP.NET Web API, both synchronously and asynchronously, and also how you can expose your step functions using Amazon API Gateway without having to write any code. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is part of my .NET on AWS series and thanks to AWS for sponsoring it. Here I have a simple ASP.NET API application that I'll be using today to trigger our AWS step function workflows. Let's first add the NuGet package that's required to interact with step functions. So right-click, Manage NuGet Packages, and search for step functions in here. And we can add the AWS SDK.stepfunctions NuGet package. Let's also add the AWS extensions netcore setup to make dependency injection easier. If you're not familiar with this package, check out my linked video here, which talks about how to use this to set up dependency injection. So once the NuGet packages are installed, let's come back to our application. Let's register the builder.services.add AWS servers and the iAmazon step functions interface. Now this is required to interact with step functions. Now once we have that added, let's add our first API endpoint to invoke a step function workflow. Now I have some of the code already written here, so I'll be just adding the endpoints and then walking you through the application code. Now here we are creating API endpoint to invoke the user onboarding workflow. Now in the previous videos, we created this in our workflow in step functions and we have the user onboarding. Now if you want to synchronously execute workflows, you cannot do that with the standard workflow. Now this is what we use to create the user onboarding. Now for this demo where we are going to show synchronous workflows, I have created an express workflow. So you can see the type here as express of the exact same workflow that we had before. So if I navigate into that and click edit, you can see the full workflow structure where we were saving this into DynamoDB, invoking a Lambda function and sending a message to SQS. Now, if you are completely new to how to set up all these, check out my previous video on step functions and how to integrate with AWS services. So for the synchronous demo, we will be invoking the express workflow. So let's come back to our code and let's navigate to this function which handles this endpoint. So here we have the request coming in as a post from the body. And we also inject in the iAmazon step functions interface, which we just registered in our dependency injection. Now we are also getting in options pattern and setting up the step functions options. Now all this has is the details of the workflow that needs to be triggered. Now I have added this in app settings.json and you have the values in here. You can see there's workflow ARN express and the workflow ARN. Now both of these are the ARN of these workflows that I have copied from the AWS console. So you can copy it from the ARN and use this to invoke these workflows. Now, if you're not familiar with the options pattern, I highly recommend checking out my linked video in my ASP.NET series. Now, we are doing some check on the request body. Once it's not valid, we continue the processing. And here we are serializing the JSON request into a string input. Now, our workflows depends on a user input, which is case sensitive. Now, when we created the workflow, we used camel case options for the property names, which means it have to match when we send a request to it. So in here, when we are serializing it, I'm also specifying the camel case options. Now, this is just passing in the JSON serialization options and informing that to use camel case. Now, once we have the input, we can create a start sync execution request. Now, this is coming from the NuGet package that we added for step functions. So here we are specifying the state machine ARN that should be invoked and also passing the input that we just JSON serialized. Now, once we have the request, we can use the step functions and call the start sync execution async method and pass in the request object. Now, since this is a synchronous request, it is going to get back the result, which means it'll have to wait for the entire workflow to finish. Now, this is the reason why it doesn't support for standard workflows, because standard workflows can span for a longer duration, whereas express workflows has to be less than 5 minutes. Now, once we have the result, we are just returning back an OK or a bad request. Now, let's run this and see this in action. So we have the post API request. Let's try it out. And let's click execute after putting our user details. Let's paste in some valid user details and let's click execute. Now this is going to trigger our API and it's going to hit the workflow, which means we should soon be starting an execution here. So you can see this is running and it's going to execute this workflow based on the input that we just passed. Now, if you look at the input, you can see the entire input that we just pasted in our API in here. Now, this is saved to DynamoDB, invoked our Lambda function, and sent the SQS message. Now, if we look at our response, you can see the response is also saying it is 200 OK, which means the request was successful. Now, if we were to create an invalid exception, so let's pass in the source as invalid and click execute. This is again going to trigger an execution of our workflow. So let's navigate back and you can see the execution here. Now, in this case, this has again succeeded, but you can see the Lambda function has error, but the error handling that we had put in our Lambda function has caught this and successfully continued the workflow. Now, we did walk through the exception handling in a previous video on step function exception handling. Now, if this workflow was to abruptly end and error out, it will return a failure response in our API. Now, with the synchronous flow, the user needs to be waiting after making a request for the entire workflow to complete. So this is usually not a great experience from a user perspective. This is where you can trigger the workflow asynchronously and then wait for it to complete in the background. So let's see how we can add the asynchronous flow. For simulating this, I have two API endpoints, which is to trigger a process user onboarding asynchronously and also to get the status of the workflow. So let's walk through this. So in this case, the process onboarding is doing the exact same. Instead of calling the start sync execution async, this is calling the start execution async, which means it is going to asynchronously execute this exact same request. The rest of the code is exactly the same. The only case is that we are triggering this asynchronously. Now, I also have another endpoint, which is to get the status. So if we look back at that, this is going to return back the status given an execution ARN. Now, the start execution async response returns us an execution ARN that we can use to monitor the status of the workflow. So if we switch back to our console, you can see each of these executions that we are navigating into has an execution ARN associated with it. Let's see the asynchronous flow trigger. So for the asynchronous execution, we can use the standard type workflow. So in the application code, I'm using the workflow ARN, which is of the standard type, which is the ARN of the standard workflow. So let's run this again and let's see this in action. So we have two more endpoints in our Swagger. So let's trigger off the process user onboarding. Let's click try it out. Let's paste in the user details and let's click send. Now this has triggered the workflow, so you can refresh here and you can see the new execution. Now the response also returns the execution ARN. So let's copy this and let's use this in our subsequent endpoint to get the status. So let's pass in that execution ARN and click execute. And this is going to return us that it has succeeded and the output of the execution. So if we navigate back to our status, you can see this is succeeded and it has also returned the status in our API endpoint. Now, if this was a longer running workflow, you would be seeing the execution status of running. Now, to simulate that, let's edit this workflow and let's introduce a wait state inside this. So let's drag and drop a wait and let's wait for 20-30 seconds. So let's put 30 seconds in here. Let's save this. Let's navigate back so that we can see the executions and let's come here and click the execution again. So let's send the same request body. Now you can get a new execution ARN for this. So let's copy that and let's paste this inside to get the status. Now in this case, you can see the status is running because we have put in the wait state. Now if you refresh this, you can see this is still running because it is waiting in that wait state. Now once 30 seconds has passed, it will continue this execution and return back the result. So you can see the execution is completed. So if I navigate back and make a request again, you can see the status is succeeded. So we've seen how you can use .NET code to trigger your AWS step functions. Now in this case, we had to write application code to set up an endpoint to trigger these functions. Now this might be very well what you want in your application scenario, but what if you want to simply expose this as an API endpoint? So if you are using API gateway in Amazon, we can easily do that. So let's see that example. So let's open a new tab and let's go to the API gateway and let's create a new API gateway. So let's click create an API. Let's choose HTTP API and click build. Now in this case, we'll specify user onboarding API. Let's click next. Let's configure the routes later. So let's click next again and next and create this endpoint. Now this has created a REST API endpoint for us. Now let's create a root inside this. Let's call this as post and let's create a new endpoint saying /new user and click create. Now in this new post endpoint, we can attach an integration. So let's create and attach an integration. In here, let's choose AWS step functions and let's specify the integration action. In this case, we want to start execution. So let's click start execution. We need to specify the state machine ARN. So let's navigate back to our user onboarding. Let's copy this ARN and let's paste this in our gateway. Now we also need to specify an invocation role. So this role needs to have permissions to talk to step function and make the execution and start the execution. So let's open a new tab and create the role first. So let's navigate into IAM. Let's navigate to roles and click create role. So let's keep AWS servers. Now, since this is for API gateway, let's search for API gateway and click next. Now, this is by default adding the permissions to push to CloudWatch logs. So let's navigate to next. Let's complete creation of this and let's add in the permissions to talk to step functions. So let's specify this as user onboarding, API gateway, step functions role. Let's leave all of these as default and click create role. Let's navigate to this role that we just created and let's add an inline policy to talk to step functions. So let's choose step functions from here. Now in here, all we need to do is the trigger execution. So let's say start synchronous execution and also start execution, depending on how you want to trigger this API. Now we can also restrict this specific ARN. So let's paste in the ARN of the state machine that we want this to talk to and click add ARNs. Let's click next. Let's give this a name and let's click create policy. Now we have attached the policy to call the step functions. Now once we have this, let's copy this role ARN and let's come back to our API gateway and paste this in here. Now since we need to pass a request into our gateway, let's do that in here. So we can map the request from the API gateway onto the workflow. So we'll use the exact same format and specify $request.body.input and let's click create. Now this has created a new API endpoint and it has set up the integration. To see this in action, let's navigate to the deploy in stages, which is getting automatically deployed. So let's use this URL to invoke this gateway endpoint. Now since this is a post endpoint, we will be using Postman to trigger a request. Let's create a new request. In here, let's choose post, paste in the URL, and the endpoint is new user. Now we need to pass in the request body. So let's paste in the request body. Now I have wrapped this user in an input because we used request.body.input. So it is expecting an input parameter to wrap this user info. So anything that's coming under the input will be forwarded to our step function. So once we have all of these, let's click send, which is going to trigger our workflow. So you can see we get back the execution ARN of the workflow that is being triggered. So if I navigate onto our state machine and refresh here, you can see this is still running. So this is the request that we just triggered from our API gateway. Now, once this is completed, you can similarly get the status by passing in and getting the status of the workflow. Now, if you want to do that, you can expose another API gateway endpoint to do exactly the same. So with the API gateway integration, it's much more easier to expose an API endpoint to trigger your workflows. Now, depending on what your use case is for your application, you can choose either of these mechanisms to trigger your workflows. In the upcoming videos, we will explore how to integrate step functions and trigger them using Event Bridge or when a message comes into SQS, etc. We'll also learn how to set up build deploy pipelines for your step function workflows. If you want to be notified when those videos come out, please make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.